I'm research scholar of J2H Hyderabad. Now today my paper is performance evaluation of software applications on heterogeneous architecture. Nowadays power issue are increasingly significant in modern process. Nowadays everyone wants to reduce the power. That means we want to reduce the power as well as without degrading the system. That means we have to processing with efficiently and very fast, but at the same time we want to reduce the power consumption. It is a critical issue that power and energy trade-off made visible to the chip architecture, compiler writers and circuit designers. Most existing power analysis tools achieve high accuracy by calculating the power for designs only after layout, not for beginning. After layout only we are calculating the power. But here our framework analysis and optimize the software applications on heterogeneous architecture. In recent years, continuous development in silicon technologies, it is possible to implement complex electronic system in a single integrated circuit. That means, for example, one mobile system. Nowadays, in mobile, we can send the mail and we can see the video and we can take the video and we can take the picture and we can make the calls. That means we are gathering all the different requirements in one complex electronic device, and that is high level of system integration and need to deliver in the short time. That is mobile. We are using the fast transaction by using the mobile. So here in mobile we are gathering all the features in one architecture. So a graphing, here the main is the graphing processing unit, which is GPU, is also called as visual processing unit. In dedicated graphics rendering device for workstation gaming. Nowadays everyone knows that what is the graphic. Graphic means nothing but 3D animations which shows the reality and which shows the some graphical and which shows some animations. GPU is a most powerful. Why? Because GPU contains the parallel structure more effective than the CPU. Why? Because CPU contains only serialized structure and it contains the less cores. But whereas in GPU it contains thousands of efficient cores for parallel processing. For parallel processing, GPU is not only to display and it contains the 3D engine, video engine and display engine. 3D engine is used to provide the transparency, reflection, various gaming control, various effects like water effect, shading effect, animation, real-time 3D action, etc. And operating system cannot communicate directly to the system. Why? Because it cannot communicate directly. For that we need the drivers which will control the particular hardware. See, this is the graphic processing unit which contains the 3D engine. It shows the transparency. That means it displays in different view. And whereas in display means that we want to screen bigger and we want to reduce the brightness or like that. And here we can also do in video engine. See, we can do the camera and we can do the video compression. That is means we are video which is taken much data, we are compressing. That means we are reducing the data by encoding, and next again at the user end side we can decode it the zip, just like zip file where we can zip the more data in less, and again we can open that zip file, again we will get the same as is the data. See, DirectX is a set of application program interface where it provides the developer resources to write the Windows based application that access hardware feature of the computer without any knowledge. This is introduced by the Microsoft. This is a product of the Microsoft. They introduced that DirectX, which contains this set of APIs. The interfaces provided by the DirectX software developer can take the advantage of hardware features without any implementation details of the feature. That means without any knowledge of the hardware, he can implement that. So related work, see, CPU and GPU is a powerful combination and move the data between them easily. John Dee as his authors describe that GPU is a powerful and highly parallel because parallelism is a future computing. Bothina described the extension of the Intel production graphics driver to support the virtual memory heterogeneous multi-threading programming model. Intel graphics device supports both 3D graphics re-rendering software stack and new classes of heterogeneous multi-thread applications which can support the Intel architecture which contain the CPU cores and it also support Intel integrated graphics and Intel media accelerator in same virtual address. That means, see, in Intel 3D graphics, it contains both CPU cores as well as integrated graphics and graphic media accelerator. DirectX has a future, same DirectX has a future. We designed the DirectX 11 which contains the features of the DirectX. But what we are doing means we are reducing we are compute the shading technology by using the direct computing technology which is integrated with 3D. Here we are using one technology, that is tessellation, can be used to render as a single model with various levels of details. That means we are gathering various levels of detail, at the same time we are showing only in single model. It is implemented on the GPU to calculate smoother curved surface from a course. That means with less details input. Patch face is divided into smaller triangular face for better approximate surface. Again we are gathering into one by using the tessellation. See, we are re-rendering the pipeline system. Here we are fetching the vertex data and again we are going to shade that vertex data. Here we are using rasterizer which converts the vertex into the pixel. So again we are going to the pixel shader and again we are going to the pixel output to the frame buffer. See, we are using this, we implemented this technology because see vertex that means some group of lines connecting in one, and where we are going to the pixel means small dot, that means group of lines we are converting into single pixel. So Microsoft 3D API defines the process to convert the group of vertices, texture, buffers and stages into image on the screen. Direct 3DX 11 which we designed the pipeline explained re-rendering pipeline with several stages. One is input assembler which reads the data and a vertex shader which we are going performance on a single vertex at a time, and full shader operations on set of patch control points and generate extra data. Tessellation stage, already we know that divided subdividers to create higher order representation. Domain shaders, operations on vertices output by the tessellation style. Next, geometric shader, process entire primitive, and where we have stream output means we can write the previous results to the memory. Rasterizer which converts the primitives into pixel, and pixel shader we are determine the final pixel color to be written at the target. And output merges means it merges the various output into single stage. But this all methods need not. Only we need three stages, that is we designed in 3D11 only with three stages that implement the tessellation. One is half shader stage, second tessellator stage, third one is domain shader stage. Whereas tessellation provides the geometrical patch like triangle, quadrilateral, like that, and tessellation which gathers the different outputs into single stage, and domain shader means it calculates the vertex in which position that vertex is. By implementing tessellation in hardware graphics pipeline can be evaluate lower details models and render into higher details and save lot of memory as well as bandwidth. That means we can save the lot of energy as well as bandwidth also. Why? Because we are converting into pixels. That means we are we are compressing the data into pixel by reducing the memory as well as bandwidth, then automatically, definitely we can reduce the power. The direct 3D11 pipeline implemented translation in hardware which offloads the works from CPU to GPU. Now we design this 3D11 pipeline which we are going to the vertex stage. Here we are going to the shader for the vertex, and next we are going to the half shader which provides the geometric face like triangle, quadrilateral, and next translation stage means different levels we are considering into one single higher level. And domain shader which calculates that vertex the position, and next it converts the geometric stage. So by this geometric stage, that means it as well stage, again we will get the as well stage. By this we are reducing the memory and bandwidth also. So here we got some of the results which some screenshots of that results. And next we used here watch simulator for calculation the power values. See, we draw the one graph energy consumption before optimization, this pink one, energy consumption before optimization, energy consumption after optimization, green one. See, we are consuming the energy which are in green one, and we before that which is pink. That means we reduced that energy and as well as the power by using this technology 3D11, which will reduce the memory as well as which will reduce the bandwidth, so that we can automatically can reduce the power as well as the energy consumption. And see, we are using one watch simulator for calculation power and consumption. So this is the excellent tool which can calculate the power analysis. So some of the I referred some of the journals. So and thank you for, and I really thankful to my guide Dr. M. Rajshekhar Babu, where he really is good guide. That means he is not only guide, he is just like a friend with us, and he is always forcing me to do this work, that work. Again he will stay up to night 11:30 also. That means he is always encouraging with the students, and I really thankful to my co-guide Dr. A.B. Shivkumar sir, and he is also very he is also very energetic guide, where he are always forcing me to do better and better and more some different ways, and I really thankful for giving this opportunity.